Good evening, and thank you for attending our program, The Heavy Water War, Stopping Hitler's Atomic Bomb. Our presenter is Timothy Boyce. Mr. Boyce will explain how Nazi Germany's leading attempt to develop an atomic bomb was thwarted. It is a story of extraordinary courage and endurance by Allied commandos. In covert missions, the stakes had never been higher. One of these missions happened in February 1943, 83 years ago. This presentation is sponsored by the Friends of the Hamden Library. My name is Elisabeth Angele. I am responsible for information and patron services at the Hamden Public Library. Before I introduce our presenter this evening, I would like to do some Zoom keeping. Please note we will record this program. I will send out a follow-up email with the recording link. We plan to upload the recording to Hamden Public Library's YouTube channel. Thank you, Tim, for giving us permission. To achieve the best sound quality, everyone should be muted. When you want to participate in the discussion, please unmute yourself. There are different ways to do that. On the microphone icon on the left-hand side of the Zoom toolbar, simply click on that or hold down the space bar on your computer, or hold down the Alt key and the letter A. Once you have finished sharing your thoughts, please mute yourself again. We will have a question and answer session at the end, for which I will stop the recording. You can also ask questions through the chat. For information on future library programs, please go to our library website, hamdenlibrary.org. Click on Programs. On our website, under About Us, you can also sign up to obtain our library newsletter via email. It gets sent out twice a month. It is now my great pleasure to introduce our presenter this evening, Timothy Boyce. Timothy Boyce, a Connecticut native, practiced law for many years, most recently serving as the managing partner of the Charlotte, North Carolina office of Dechert LLP, an international law firm. He specialized in commercial real estate finance. He holds an MBA from the Wharton School of Finance and a JD from the University of Pennsylvania Law School. He received a BS in Foreign Service from Georgetown University. Tim's articles have appeared, among others, in the Quarterly Journal of Military History, World War II magazine, the Scandinavian Review, and Viking magazine. Tim, who currently lives in Tryon, North Carolina, retired in 2014. History is his passion. He devotes much of his time to speaking and writing. I would like to mention that Tim's 2024 presentation on the secret concentration camp diary of Ott Nansen is available for viewing on Hamden Public Library's YouTube channel. Tim was able to bring this diary back to print in 2016. It was out of print for more than 65 years. The historian David McCullough famously said, "History is a guide to navigation in perilous times." Thank you for presenting this evening, Mr. Boyce.
Terrific. Well, thank you, Elizabeth. Thank you so much for that introduction. Let me pull up my slides and we can get going here. So go to share and okay. I'm assuming you can all see those slides. Um, Again, I thank you for that introduction. I thank all of you in the audience for signing up for this. I hope you all survive the great blizzard of 2026. I've heard lots of horror stories about lots of snow. As Elizabeth was kind enough to note, I am a Connecticut native. I was born in St. Raphael's Hospital in New Haven, Connecticut. Grew up in East Haven and went to high school in West Haven, Notre Dame, which plays Hamden every Thanksgiving. My father started taking me to the Green Bowl when I was about 5 years old. I've hiked probably every trail on Sleeping Giant that there is. I'm still a member of the Sleeping Giant Trail Association. So I've got a lot of links back to Connecticut. So this feels like a little bit of a homecoming to me. Um, and as Elizabeth was kind enough to point out, I did give a presentation about a year and a half ago, a live presentation about a diary written by a Norwegian named Odd Nansen. The name of the diary is From Day to Day, and he was a prisoner in different concentration camps for 3.5 years. Um, it's a long story. It would take me another hour just to go even tip into that. But the point I wanted to make here is that in editing and republishing that diary way back in 2016, I really had to learn about everything that Nansen mentions in his diary. And there's a particular diary entry that I'm going to read to you. This is from Saturday, March 6th, 1943. So we're coming up on the anniversary of this date pretty soon as well. And Nansen wrote in the diary, the news was excellent, but still with no essential points. There has been sabotage in Vemork. The heavy waterworks are destroyed. 4 Norwegian-speaking men in English uniform got away. And then he goes on to talk about other things. And just that short mention of Vemork in the heavy water is what kind of set me on the path of finding out everything I could about the so-called heavy water war and the competition to build an atomic bomb. Now, if I were standing in front of all you, I would ask for a show of hands to ask how many of you have seen the movie Oppenheimer. Of course, that's not possible here. My experience has been in the audiences that I've spoken to is practically everybody has seen it. I mean, I guess it is one of those kind of must-see movies. I guess it won the Best Picture Oscar a couple of years back. And in fact, there is one mention in that movie. I can't tell you exactly at what point it is, at the 1.5 hour point or something, but there is a mention of heavy water in that movie. And one thing that at least comes out loud and clear to me in watching that movie Oppenheimer is how real, how palpable the fear was on the part of the Allies that number one, Germany was trying to develop an atomic bomb, and number two, that Germany probably had a significant head start over the Allies. Now, one thing that's not mentioned anywhere in the movie, and I've actually never seen it kind of set out quite this clearly in any history book that I've read about the development of the atomic bomb or kind of the race to build it. But in 1939, the very beginning of World War II, it was Germany, not the United States, that was considered to be the preeminent power in the scientific power in the world. German scientists had won by far and away more Nobel Prizes in chemistry and physics than any other country. In fact, if you add them up from 1901, which is when the Nobel program began, until 1939, German scientists had walked away with 28 Nobel Prizes in those two disciplines. The next highest total, national total, were the British. They had 14 Nobel Prize winners. Then came the French with 8. And then in fourth place came the Americans with 7. That's 1/4 of the number of Nobel Prizes given out to the Germans. So the story I'm going to tell you today begins, as that saying goes, kind of long ago and far away. So let me pull up my next slide here. Make sure it's working. It begins in a tiny little hamlet in south central Norway called Ryukin. And I know this is kind of a crowded slide, but you can see if you look to the right of where the little marker is, that Ryukin is located about 150 miles, exactly almost due west of Oslo, which is just on the right-hand side of this slide. It's located in a very mountainous, rugged country at this point. Um, and it's Ryukin is just a tiny little hamlet. Now, before I go to my next slide, I just want to point out one other thing on this particular slide. If you look just to the north and the west of Ryukin, you can see this kind of shaded grayish blob. And that, I know the typing, the letters are very, very small there. That is the Hardangervidda National Park. And the Hardangervidda is Europe's largest high alpine plateau. And that's going to play a role in the discussion that we're going to have on this. So it's important to kind of know where the Hardangervidda is in relationship to Ryukin. So we know that Norway is blessed with many things, and certainly one of the things it's blessed with are lots of very, very big mountains. Only about 30% of Norway's land is arable, is farmable. And when you have lots of big mountains and you're located in the northern latitude, those mountains collect a lot of snow in the wintertime. And come spring, summer, fall, a lot of that snow melts and it comes rushing down the sides of these mountains. And if you can channel some of that water, pass it through a turbine, you can generate hydroelectric power. And so in 1906, the Norwegians, who were kind of, I guess, feeling their oats to a certain degree, because they had just achieved their independence from Sweden. Norway was part of Sweden from 1816 until 1905. As I say, now that they're independent, they announced to the world that they are going to build the world's largest hydroelectric plant in Ryukin. Okay. Now, a close-up map of Ryukin shows you here. Ryukin's kind of dead center in the middle of that slide there, and you can see it's on the shoreline of the Mona River. If you look to the left there, you see a large lake called Mosvatn. Mosvatn is surrounded by a lot of very, very steep, tall mountains. They all drain down into that lake, Mosvatn. It in turn then drains into the Mona River, which cuts a very deep channel, a kind of a cleft through the mountains there, and then finally empties into yet another lake on the right-hand side, Lake Tinjo. Now, if I could show you a three-dimensional idea of what this very, very steep canyon where Ryukin is located, it would be you'd have two, very steep sides, and then as they get closer and closer, and they get to be about maybe 250 yards apart, they drop down into a very, very steep canyon, like a slot canyon that's a further 600 feet almost straight down. To give you an idea how steep this little canyon is, how narrow it is, for about 5 months out of every year, there is no sunlight in Ryukin. The sun, actually, the rays of the sun are not at a steep enough angle to make it all the way down into the bottom of this canyon. So this is where the Norwegians have chosen to build this hydroelectric plant. Now, the cost of developing this in the wilderness out there was enormous at the time. It was said that the cost to develop this hydroelectric plant was equal to twice Norway's annual budget. It was an enormous, enormous undertaking. And the question is, why were the Norwegians going to so much trouble to build not just a hydroelectric plant, but the world's largest hydroelectric plant? Well, it certainly wasn't because Norwegian consumers were screaming they needed more electricity for their cell phones, laptops, flat screen TVs, electric vehicles, microwaves, toaster ovens, electric toothbrushes, you name it, you get the picture. Because none of that stuff had been invented at that point. So why were they creating all of this electricity? Well, the answer to that riddle can be named in a single word, and that is fertilizer. Now, the beginning of the 20th century, the world's population is growing rapidly. People are living longer, eating better. The demands on farmers to be more productive, to produce more food for this global population is growing very, very intense at that point. Lest you think I'm kidding you about the importance, the prominence of this issue about fertilizer, I'm going to read to you an excerpt. I think it's very, very timely because this is an excerpt from the President's State of the Union address. not the current State of the Union address, but the State of the Union address given in the year 1850. And I usually ask the audience if anybody can tell me who the president was in 1850. I actually got one person who knew. It's Millard Fillmore. Okay. As part of his address to Congress, and of course, we know the State of the Union address is purportedly the most important address the president gives, laying out the agenda for the government, the highest priorities. And this is part of what Millard Fillmore said to Congress. He writes or says in a speech, I think it was actually delivered in writing, Peruvian guano has become so desirable an article to the agricultural interests of the United States that it is the duty of the government to employ all the means properly in its power for the purpose of causing that article to be imported into the country at a reasonable price. Nothing will be omitted on my part for accomplishing this desirable goal. Now that's 1850. Fast forward 50 years to the turn of the century, and the demand on farmers, again, to be more productive has grown even greater. And organic fertilizer, what you and I more commonly refer to as manure, including Peruvian guano, just wasn't keeping up with demand. The problem was that scientists and industrialists up to this point could not find a way to artificially or make man-made fertilizer. Now, the key ingredient in fertilizer is nitrogen. Nitrogen is essential to all living processes. And nitrogen is actually quite prevalent. 78% of the air that you and I are breathing right now as we speak here actually consists of nitrogen molecules. The problem is that nitrogen in its normal state, its resting state, is very stable, very inert, doesn't mix well with other elements, doesn't bond well with other elements. And in its natural state, it's very difficult for plants to absorb. Something needs to be done to nitrogen to make it absorbable by plant life. The kind of the term of art here is it needs to be fixed. Something needs to be done to it. And it just so happens, just so it turns out, that in 1905, it's a Norwegian scientist named Christian Birkeland who finally comes up with an industrial process, an artificial process to make fertilizer. And what he does is he takes nitrogen out of the air and he fuses it together with hydrogen to form a substance that all of you are all familiar with. We take it for granted, called ammonia. And ammonia is the basic building block of all artificial fertilizer. So the reason why they were building this power plant was to feed a nitrogen fixing plant that they were building literally right adjacent to and in front of the power plant. And this took about 5 years to finally be completed. It wasn't completed till the year about 1911. And then when it was all completed, they called this complex VMORC. And here's a picture of what the complex looks like. That Lake Mosvatten that I showed you on that earlier slide, that is way up over the horizon. It's up on the Hardangervidda Plateau. And you can see where the water is diverted from the Mosvatten Lake. It is channeled to those pipes, which are coming down the side of the mountain. And all you need is gravity at that point to have the water slide down. The power plant is actually hidden, about 3/4 of it is hidden in the back of this picture. If you look to the left-hand side, you'll see a kind of a tannish sandstone classical building jutting out on the left-hand side. That is part of the power plant. It actually goes the whole length of this picture, but it's obscured by this 6 or 7 story nitrogen fixing plant that's built right in front of it. And as you can see, as I mentioned, this is right on the lip of that very steep, steep canyon that drops down to the bottom of the Mona River where Ryukyu is located. And since this VMORC complex is on the south side of the Mona River, and Ryukyu, where all the inhabitants and all the workers live, is on the north side, they had to connect these two sides by building a suspension bridge over this chasm, over this very narrow canyon there to get people back and forth. So that comes online, as I say, around 1911, and it's an immediate success once it starts producing ammonia. The investors who put up the money to develop all this, they're getting a nice return on their investment. The workers who live in Ryukyu, who before this were just kind of subsistence farmers, they've got steady jobs now that pay very well. So it's a win-win for everybody. Now, around the same time that all this is happening, there is a great ferment in the field of science. Scientists are beginning to understand the very basic building blocks of the universe, the atoms. The electron is first discovered in 1897. The proton is discovered in 1917. The neutron in 1932. And one of the scientists who's doing research on these tiny little critters that make up the universe called atoms happens to be an American named Harold Urey. And Urey is focusing all of his experimentation, all of his research on the lowly hydrogen atom. Hydrogen is the most abundant chemical substance in the universe. In fact, 75% of all matter consists of hydrogen atoms. That's everything on Earth, everything in the solar system, everything in the Milky Way, everything in the cosmos. 75% of it consists of hydrogen atoms. And part of the reason for that is that hydrogen is the simplest atom in the universe. You can't get any simpler than this and still call yourself an atom. You got one proton in the nucleus, you got one electron circling around it. Well, Urey makes three important discoveries when he's doing his research on the hydrogen atom. The first discovery he makes is that there is a slight variance uh, that exists out in nature that is ever so slightly different than the composition of this hydrogen atom. And this is they call it an isotope, a variant, in that it's got a neutron in the nucleus. That's the only difference. And because it has two items, a proton and a neutron, in the nucleus, he gives it a distinguishing name calling it deuterium, after the Latin word for two. Now, scientists, of course, love to classify everything so they can understand and put it in neat boxes and kind of gain some understanding. And scientists classify all atoms in accordance with what they call their atomic weight. Now, when we talk about atomic weight, we're not talking about scientists taking tiny little atoms and putting them on tiny little scales and trying to figure out how much they weigh. Atomic weight is nothing more than the arithmetic sum of all the neutrons and all the protons in the nucleus. And so if we go back to my earlier slide, the atomic weight of hydrogen is 1. The atomic weight of deuterium is 2. Now, of course, 2 is greater than 1. In fact, it's twice as big as 1. So to distinguish this variant of the hydrogen atom, he gives it a kind of a nickname, and he calls it heavy hydrogen. Now, we're all familiar, even if you out there got a D in high school chemistry, we're certainly all familiar with the composition of water molecule H2O, two hydrogen atoms, then bonded together with one oxygen atom. Well, the second discovery that Urey makes is that out in nature, there are cases where you have deuterium atoms, not hydrogen atoms, bonded to oxygen. So instead of H2O making up water, this is D2O. And to distinguish between these two variants, he calls this right-hand variant, which has heavy hydrogen bonded to oxygen, he calls it heavy water. Now, the third discovery that Urey makes is that he can separate heavy water molecules from regular water molecules through a process known as electrolysis. He forces an electric current through the water. It forces the heavy water molecules to migrate in one direction, the rest of the water molecules to migrate in the other direction. I can't explain to you why. I'm not a scientist. I'm just a retired lawyer, but that's what he was able to accomplish. Now, the heavy water molecules that he is able to collect are very rare. First of all, deuterium itself, heavy hydrogen, is very rare, exists in nature, but not much of it exists in nature. And these heavy water molecules, where it's bonded to oxygen, are even more rare in nature. In fact, in nature, the ratio between heavy water molecules and regular water molecules is 1 to 41 million. It's quite a discrepancy, okay? So heavy water is very scarce. Now, the as I said, the way you make heavy water, of course, is by or creating it is through a process known as electrolysis. So just to kind of recap, If you want to make heavy water, you got to start with number one, unlimited amounts of water, and number two, add unlimited amounts of electric power. So, what facility perhaps comes to mind as maybe a good place to produce some heavy water? Of course, it's VMORC. VMORC, has more water than they know what to do with, has more electric power than they know what to do with. And the Norwegians, who are no dummies, who are familiar with these developments. By the way, Urey will receive the Nobel Prize in Chemistry in 1934 just for these discoveries. That's how important they were at the time. And the Norwegians say to themselves, hey, look, we've got a competitive advantage over just about anybody else in the production of heavy water. We can produce it at a lower cost than just about anybody else, given the size of our power plant, et cetera. Now, so they decide they're going to make heavy water. Now, there's one kind of glitch in this analysis, which is that nobody knows what in God's green earth heavy water is good for. At this point, all they know is it exists out there, but they don't know what special properties it has. But in any event, there's enough scientific interest in this that the Norwegians open up a heavy water facility, a processing plant in the basement of that nitrogen fixing building that I showed you in my earlier slide. And this is kind of built on the theory of, hey, if we build it, they will come. And as I say, there is this kind of initial flurry of interest. So they go into production in 1936, 1937. I mean, they only produce about 10 or 20 gallons over the entire year, given how laborious this process is. And this continues until 1938, the end of 1938. And by then, it's becoming painfully apparent to just about everybody that nobody can figure out what heavy water is good for. It turns out heavy water doesn't make plants grow bigger, faster, stronger. It's not the fountain of youth. It doesn't extend people's lives. There's nothing that scientists have been able to figure out what it's good for. In fact, the only thing that scientists are able to conclusively say about heavy water is that it's got a higher melting freezing temperature. Whereas regular water turns to ice at 32 degrees, heavy water turns to ice at around 39 degrees Fahrenheit. That leads at least one wag to observe, well, maybe the only thing heavy water is good for is ice skating rinks. Think about it. If you build your ice skating rink with heavy water, it could be a balmy 37 degrees out, and you can still use it and practice your triple axels and get ready for the next, quadrennial Winter Olympic Games, where everybody else who's relying on regular ice, if it's 37 degrees, all they got is a slush puddle. So by beginning of 1939, it's becoming apparent that there really is no market for heavy water, and the Norwegians are just about ready to kind of give up. They gave it the old college try, and it didn't work. They thought it might lead to something, but it didn't. In the meantime, as I said, there's this great ferment going on in the world of science with the understanding of these basic building blocks, the neutron, the proton, and the electron. Especially with the discovery of the neutron, scientists are able, because a neutron has no electrical charge, whether positive or negative, they're able to use neutrons as a way of kind of understanding the properties of all these different atoms out in the universe. And what scientists do is they fire neutrons at the nucleus of different atoms to watch what happens. I kind of view it as a way, we think of understanding the body by doing dissections. This is a way of kind of dissecting this core of these atoms to see what happens. And that gives rise to a whole emphasis in physics on the performance of the nucleus, because all the mass is in the nucleus and mass equals energy. And that gives rise to what we call nuclear physics. And with scientists, when they fire these neutrons at these different atoms, usually one of two different things happen. Usually, either the atom absorbs that new neutron into the nucleus, thereby changing it, turning it into an isotope, ever so slightly different atomic structure. Or in other cases, it turns out when you fire that neutron into the nucleus, it absorbs that neutron, but it ejects another neutron, thereby preserving its atomic structure intact. Well, in Germany, there are two scientists named Otto Hahn and Fritz Strassmann, and they're doing their research on the uranium atom. Now, the uranium atom is the complete polar opposite of the hydrogen atom, as you can see here. It is a big, dense, gnarly beast. It has an atomic weight of 238, 92 protons, 146 neutrons packed into that nucleus. And when Fritz Strassmann and Otto Hahn fire a neutron at a uranium atom, two unusual things happen. The first thing that happens is when you fire that neutron in, it doesn't just absorb it into the nucleus. It doesn't absorb it into the nucleus and eject another neutron. In fact, the nucleus itself splits into two smaller, lighter elements. And when it does that, it releases some energy. Because if you stop and think about it, what was holding the nucleus together in these large atoms like this? It's so enormous. Why doesn't all just kind of fall apart? Why doesn't gravity pull all of these protons away from the nucleus? I mean, if I took a handful of marbles and held them up and then let go, they would all just scatter. There's nothing holding them together. In that glue that's holding together this nucleus, it's called binding energy. And when the nucleus splits, you don't need that energy to, like that glue, to hold those two halves of the nucleus together. That energy gets released. Now, when a single uranium atom splits in two like this, the amount of energy it releases is enough to move a speck of dust or maybe a grain of sand no more than a millimeter. That's it. That's all that happens. But it's the second part of this experimentation that these Germans undertook that kind of changes the whole equation, which is not only does the nucleus split into two lighter elements, but at the same time, it ejects two more neutrons. So if you've got two more uranium atoms nearby, they're going to split, releasing now four neutrons with energy, then eight neutrons, then 16, then 32, then 64, then 128. I can't do the math after that, but you get the idea. And that's called a self-sustaining chain reaction. Once you've started this, once you start splitting these atoms, they're going to go off on their own as long as there's any uranium atoms nearby for these protons to split. Now, if I were to get my hands on 1 single gram of pure uranium, we're talking about a gram is 35 1,000ths of an ounce. I mean, we're talking about something that's probably smaller than a little dash of rice, one little piece of rice. Well, that 1 gram contains, if it's all pure uranium, contains 25 sextillion uranium atoms. Now, if I could get my hands on 5 pounds of uranium, we're talking about 2,272 grams. So if you take 25 sextillion, raise it to the 2,272nd power, and you have all of those uranium atoms splitting within a nanosecond of each other, yes, you've got yourself a mushroom cloud. And that's what a nuclear explosion essentially is. So, of course, at this point, this is all theory. Nobody has actually produced at this point a self-sustaining chain reaction. And the question is, how do we do this essentially without blowing ourselves to bits in the process? Well, scientists thought about it and said the only way we're gonna be able to do this is to control the activity of these loose neutrons. If we can slow them down, if we can moderate how quickly they're splitting other uranium atoms, we can kind of get this energy out of control, under control rather. And that, in essence, is what we are doing when we build nuclear reactors. I mean, nuclear reactor is essentially nothing more than a chain reaction that's going on at a pace and at a rate that we can control the amount of neutron or electrons that are being emitted and the amount of energy that's being released. So, kind of to take a baby step to get to a nuclear bomb, you first got to build a nuclear reactor. The other reason why nuclear reactors are very important is if you can build one, and again, I don't understand completely the science behind this, but you can use uranium, different kinds of uranium, and turn it into plutonium, which is a fissile material that you can use for atomic bombs. So the race was on now to find what was called, as I say, an appropriate moderator, something to moderate the activity of these neutrons. I mean, just to kind of do a thought experiment, if I was standing in front of you and I had a bucket, an empty bucket, and I had a marble, and I let go of that marble, it's going to hit the bottom of that bucket pretty fast. The gravity's going to pull it down. If I add that bucket with water and drop a marble, it's still going to hit the bottom of the bucket pretty quickly, but not as quickly because the friction of that water is going to slow down the speed of that marble. If I add molasses to the pail and then drop a marble, I could probably go out to lunch and come back before that's going to hit the bottom. So that substance is what scientists were looking for. And after much experimentation, scientists are finally able to conclude that there's only two substances in the world that act as appropriate moderators of this neutron activity. One is pure graphite, and the other happens to be heavy water. Now, interestingly, the Germans, despite their scientific prowess, and as I said, they were in the forefront on so many things, they mistakenly conclude that graphite doesn't work. Now, as I understand it, the graphite they were using just wasn't pure enough. Now, they may have been using graphite that was 97, 98, 99% pure, but it needed to be something like 99.999% pure. And so the German scientists mistakenly conclude that the only moderator that works is heavy water. And of course, all eyes turn towards Vemork in Norway. And in the fall of 1939, just as World War II is just getting underway in Norway, and of course, Germany kicks it off on September 1st, 1939, when they invade Poland. That's when the Germans approach the Norwegians and say, "Hey, Norwegians, remember that heavy water that you were trying to sell to everybody around the world? Um, by the way, if you've got any left over, we'll buy all of it. And in fact, if you go back into production, start making heavy water again, we'll buy all of that, every bit that you can produce. Just name your price." And of course, the Norwegians, who are no dummies, who know about these experiments that have been going on, they stall for time. And they write back to the Germans and say, "Hey, Germans, thanks for your interest in our heavy water. Would you mind telling us what you plan to do with these enormous quantities that you're, asking to buy?" And of course, the Germans can't very well tell the truth and say, "We want this to see if we can develop an atomic bomb and thereby terrorize all of Europe that we're in the process of conquering." So the Germans don't say anything. And that leads to kind of a standoff. And that standoff stays in place until um, the morning of April 9th, 1940, when Germany finally invades Norway without so much as even a declaration of war. Now, the Germans didn't invade Norway to get their hands on heavy water. This whole idea of building an atomic bomb was still kind of in the phase of most people believing it's science fiction, including most people in ordnance departments. The people in the military, they thought this was all kind of crazy hyperbole that these pointy-headed scientists who didn't know, anything at all were conjuring. They knew how to make bombs, good old gunpowder and nitroglycerin and things like that. This idea of splitting an atom and blowing up cities was, far-fetched. So they didn't invade Norway for that. Primarily, they invaded Norway and occupied Norway to prevent the British from occupying Norway. The Germans were afraid that the British would occupy Norway, thereby essentially cutting off all of their access to the North Sea because they would control the North Sea on both coasts. And more importantly, Germany was getting all of its high-grade iron ore from mines in the north of Sweden. And that iron ore, for about 7 months out of the year, would be shipped from these mines way up above the Arctic Circle in northern Sweden. It would be shipped by rail to ports along the Baltic coast, the Swedish Baltic coast, then put on ships cargo ships, and then sailed to Germany. Well, for about 5 months out of the year, at least back in the 1940s, all of the ports on the Baltic Sea on the coastline of Norway froze in. They were not usable for about 5 months. So the Norwegians, or rather the Swedes, had to ship their heavy iron ore across into Norway, into a port on the north of Norway called Narvik, which, since it was on the Atlantic Ocean, which meant it held the Gulf Stream, never iced open. It was open for business 12 months out of the year. They would load it on ships there, but then that ship would have to sail the whole 1,000 miles along the length of Norway's coast. So if the British occupied Norway, they could cut that off. So that's why the Germans decided to invade Norway, to preempt the British. But once they conquered Norway, and by the way, Norway actually held out longer than almost any other country in any other country in Europe at the time. When they did finally subdue Norway and it capitulated, of course, they beat a path up to Vemork and they say, "Hey guys, remember we very politely asked you about supplying us with heavy water? Well, now we're the masters. We control Norway, and we're ordering you to go into production." And with every month, they would increase the demands for how much heavy water they were demanding that this facility produce. And of course, all this word is getting back to the British, who are fighting the Germans. And so the British War Cabinet charges the SOE. The SOE is the equivalent of what we call the OSS in World War II in America, which ultimately became our CIA. It's kind of the Special Projects group. And they charged the SOE with stopping the flow of heavy water to Germany because they know what they're using this for. And so the SOE kind of looks at the alternatives they have. How are we going to be able to interdict and disrupt the flow of heavy water to Germany? Well, one idea would be to just bomb this site, just kind of blow it up in Vemork. Problem is, in the year 1940, this whole idea of precision bombing was really something that was still out of reach. The British at the time, they were happy if their bombs landed within 5 miles of their intended target. So they were very much in favor of initially what they called area bombing. We'll send bombers over to Berlin, not to blow up the railroad station in the middle of Berlin, but just rather we'll just drop bombs all over Berlin, and sooner or later we'll destroy everything, including the railroad station. So bombing was kind of ruled out. They said we could reinvade Norway and fight our way into Ryukin and try to blow up the plant. But of course, you're fighting your way into the middle of this country that once it's been subdued by the Germans, they stationed 350,000 German soldiers in Norway alone. Now, Norway's population at the time was 3.5 million. That meant there was one soldier for every 10 civilians in Norway. If we had an occupying army in the United States today with the same ratio, we'd have 33 million enemy soldiers in occupation here. So that was kind of ruled out. So it looked like the only alternative was sabotage. So the planners at the SOE start thinking about some kind of sabotage plan to see if they can disrupt this heavy water. And the first attempt kind of starts back in March of 1942 when the SOE had a whole separate branch when they were training Norwegians to be essentially sabotage agents. These are all Norwegians who left Norway after it capitulated, made their way on any kind of boat, fishing smacks or whatever, to get to England to kind of join the British and fight back against the Norwegians. And so they're being trained, highly trained as kind of sabotage experts, and with the idea that they're going to be inserted as enemy fighters dropped into Norway to kind of create havoc among the Germans. And to insert enemy soldiers in a country that's occupied by enemy like the Germans is not an easy thing to accomplish. You can only do that in the winter months. And the reason why only the winter months were suitable is you needed enough darkness so that planes leaving England could fly over the North Sea unobserved, fly over Norway unobserved, and drop their charges, through parachutes in the darkness unobserved. So you can only do that in the winter months where you've got enough nighttime, night hours to allow you to accomplish that entire mission. The problem is that if you're flying at night so that people on the ground can't see you up in the air, it's equally the case that you up in the air can't see very much of what's going on the ground. Norway at the time is under blackout orders. The Germans have ordered all outside lights to be dimmed, all your windows have to be blocked off by shades, etc. So not only can you only do it in the wintertime, but you can only do it during a full moon and no clouds, clear night. And we've all been, I'm sure you've all been out at one point in your lives, out at night on a full moon with a clear sky. And it's amazing how much you can see. I mean, you can almost practically read a newspaper. It's so the moon is so bright during a full moon. So the idea is we're going to drop some men into the Hardangervidda. These highly trained Norwegians, we're going to parachute them in at the time of a full moon. They're going to become the advance team, and this is called Operation Grouse. And this is a five-man team. We're going to drop them in by parachutes. They're in the Hardangervidda, which is this uninhabited, inhospitable, high altitude plateau. Here is a picture of what it looks like. The only thing that kind of lives there and grows there is lichen, grows on the ground. There's not even any trees. And there are reindeer herds that live off the lichen. And so the idea is we're going to drop you into the Hardangervidda. Your first job is to find an abandoned or empty hut. The Norwegian word for hut is hutta. And if you look very closely at this slide on the lower right-hand corner, you can see a little cabin right there. And the Hardangervidda is kind of dotted with these cabins. And what they really act as are emergency shelters. Their only purpose is to help people. If you're a hunter and you're out in the Vita hunting reindeer for your family and a blizzard blows up, you beat a retreat to one of these places just to kind of overwinter until the blizzard subsides. So they're very simple. They've got a couple of bunks in them. They've got a wood burning stove. They might have some basic food supplies, some wheat or something like that, some bread, and that's about it. So the idea is find one of these that's unoccupied. Since we're dropping you in the wintertime, there's nobody who's making, their full-time occupation living in any of these things. It's just too cold and too remote. Once you're there, once you've established your base, you're to reconnoiter VMORC, kind of get a lay of the land, see where the guards are, how many there are, when they change shifts, things like that. Most importantly, you're to scout among this very mountainous region like this, very uneven, to try to find a level, straight area where we can land a plane. Because what we're going to do is we're going to give you a homing device. And come the next full moon, we're going to drop in two gliders. They're going to be towed over the North Sea by two British bombers. Each glider is going to have a pilot and a co-pilot, and then each one is going to have 15 highly trained British explosive demolition experts called sappers. Now, why were they sending over 30 British sappers? Well, the powers that be, the planners, figured that they needed a minimum of at least 15 of these sappers to fight their way into VMORC, blow up, destroy the plant, and then escape. They figured if we need a minimum of 15, that means if just one of our initial group gets injured or gets killed, we've already kind of decreased the chances that we're going to succeed. But if we bring in 30, which is twice as much as what we need, we can suffer 50% casualties and still have a sufficient number to accomplish this. So that's the idea. You guys we'll have given you a two-way radio, so you'll know that we're coming. When we tell you that we're making our way with the gliders, you're to go out to the landing strip that you have found. You're to turn on the homing device, and you're to line both sides of this impromptu runway with flares. And our homing device will bring us over to where this landing place is. We will detach the gliders. They will land on this impromptu strip. You will then guide them to VMORC and let them fight their way into the VMORC facility and do whatever they have to do to destroy this heavy waterworks. The thing that's kind of left unsaid is once you've done all this, it's basically up to you to find your way out of Norway by making your way 200 miles to the east to the border of Norway and Sweden to get into neutral Sweden. So, in some ways, it's kind of like a suicide mission because the chances of you being able to pull all this off and succeed in escaping are pretty slim. I mean, most of these British soldiers didn't speak a word of Norwegian, so how they were going to pull this whole thing off is a little bit, kind of crazy to begin with. But the British at least could take some comfort in knowing that as long as they were captured wearing British military uniforms, that under the Geneva Convention, under the Hague Convention, they would be treated as POWs. And so the next month, so the initial drop off of the grouse team occurs during the full moon in October, late October of 1942. So coming a month later, it's late November 1942, the people back in England are looking at the weather report because remember, it's got to be not only wintertime, it's got to be full moon and it's got to be a clear sky. And the most important thing is that clear sky. So the meteorologists are looking at the weather report for the night of the full moon, and it's iffy. It's not really clear whether it's going to work or not work. And the Norwegian meteorologist who looks at it says, I think it's too chancy. I would not go tonight. The chances of you getting caught up in clouds where you'll have limited visibility and where you might run into precipitation is just too great a risk. The British meteorologist who looks at the same data says, no, I think it's close enough and I think we should do it. If we don't get it done within the next 48 to 72 hours, we're going to miss this full moon and we're going to have to wait another whole month for another full moon to do this. And since the pilots in the crews in the bombers are all British, since the crews in all of the gliders are British, they, their vote counts more than the Norwegian counts. So that takes off, and of course this part two, bringing in the samplers, is known as Operation Freshman. You have the grouse team, now the freshman team is coming in. And so you can see from my explanation that the chances of everything working out just right are pretty slim. Everything's got this is kind of a highly choreographed plan. And in fact, just about everything that could go wrong ends up going wrong. Plane number one arrives over the Norwegian coast, turns on its homing device to pick up the signal from the ground, and the homing device doesn't even work. It's not even functioning. So now this pilot is trying to fly blind over darkened Norway to find this tiny little landing strip tucked away in the mountains. And of course, by doing this and slowly kind of trolling around over Norway, the pilot flies through a bunch of precipitation. And when you're at 10, 15,000 feet, precipitation is going to do what? It's going to turn to ice. So ice starts building up on the tow plane. Ice starts building up on the glider behind it. It's only being held together, connected by a tow rope, and the glider gets heavier and heavier with all this ice buildup. The tow rope snaps. Now these pilots have got to land this glider in the pitch dark, and they don't even know where they are in Norway at this point. And of course, the glider crashes, kills the two pilots, the pilot and the co-pilot, as well as half the crew upon impact. Plane number two arrives over Norway, turns on its homing device. The homing device turns on, but for reasons that no one has ever been able to explain, it never picks up the signal on the ground either. Plane number two is in the same boat. They're flying over darkened Norway, not really knowing where they are, hoping to see if they can find this landing strip and these flares. And they're getting ice buildup. And sooner or later, of course, that tow rope also breaks, and that glider makes a crash landing. The pilot of plane number two realizes he's lost the glider, and so he makes a U-turn, a 360-degree turn, and flies back over the crash area to see if he can make any visual sighting on what happened to the glider. Were they okay? Were there people injured? Also to get a fix on the location so that maybe he can send that back by radio to the people in England to at least alert the grouse team as to what's happening. In the process of flying back over this site to try to see where the glider is, the bomber flies smack right into the side of one of the mountains there, killing all 8 crew members instantly there. So you got 2 crash sites. Neither one knows where the other crash site is. Neither one knows where the grouse team is. The grouse team doesn't know where these people are. So they realized the only thing we can do is essentially turn ourselves in, let the local Norwegian population know that we're here, where they are, knowing that they're going to have to instantly inform the Germans, and they figure again under the Geneva Convention, at least they'll get some medical attention for their injured um, uh, mates who've been who crashed with the gliders. What they're not aware of is that in late October 1942, Hitler issued his so-called secret commando order. And this commando order essentially said that Hitler didn't give a damn about the Geneva Convention, about the Hague Convention. If enemy soldiers were involved in sabotage or commando-like activities, even if they're wearing uniforms under the Geneva Convention, they're to be executed at once, no questions asked. So when the Norwegians apply, or when the Germans rather show up at the first crash site in accordance with the commando order, they massacre everybody right there, then and there, kill them all. The team that goes to the second crash site, the person in charge there figures he can maybe get some information by torturing and questioning the survivors to see if he can find out what they're up to. So he takes the survivors back to a concentration camp outside of Oslo called Grini, which incidentally happens to be the same concentration camp that An Nansen was in, who was writing this diary at the time. And they start questioning the survivors, and the British will only give name, rank, and serial number. And after it becomes apparent they're not going to give up any information, they're all taken out into the woods and massacred by the Germans. So the net result of this is the death of about 52 British soldiers, sailors, airmen. And the only thing that's happened is the Germans are now aware that the British are trying to get their hands on Vemork. That was the intended target. So what do? They harden the target. They bring in more guards, more searchlights, more machine guns to make it even more difficult to attack this plant. So it's back to the drawing board at this point. So having failed miserably, a number of the Norwegians who are still training with the SOE back in England, they go to their superiors and say, rather than have this very, very complicated plan, why don't we just simplify it quite a bit? Why don't we just take 6 more highly trained Norwegian commandos, parachute them in, and join up with the grouse team? Now, the one silver lining in all of this disaster is that the Germans are completely unaware of the existence of the grouse team that still holed up in the hut in the Hardangervidda. So the Norwegians say, let's drop 6 more in, augment that, so you'll have a total of 11 commandos there, and let's see if we can just, find a way to sabotage this plant. So they have to wait to another full moon. Now it's the full moon in late February 1943, and makes a successful insertion. And this is now called the Gunnerside team, the new team that's being dropped in, Operation Gunnerside. They're dropped in by parachute. They meet up with the grouse team, which has now been relabeled the swallow team. The British like to have different names for every operation so they don't get confused. And they meet up. They all go back to the hut, to the hutta. They reconnoiter again what's going on at the plant, see again how many guards are there, where they are. And they realize that there's really only 2 ways that they can get into this plant, given the location and the way it's being guarded. And one is to fight your way over that suspension bridge that I mentioned earlier in my remarks, which brings you from the north side of the Mona River to the south side where the plant is. Fight your way over the suspension bridge, fight your way into the plant, then try to blow it up. The other alternative that they look at and observe is possibly climbing down the gorge. Instead of going across on the suspension bridge, climb down the gorge, cross the river, the Mona River, which is frozen at this point, climb up the other side of the gorge. And just to give you an idea of what that gorge looks like, this is a photograph I took of the gorge on one of my trips to Norway a couple of years ago. You can see the suspension bridge across there, and you can see this is about a 600-foot drop from here down to the Mona River. This thing looks intimidating in the summertime. Imagine trying to climb down one side and then climb up the other side when you've got 3, 4, 5 feet of snow and ice there. And of course, They have no specialized climbing equipment. They don't have any ice axes. They don't have any ropes. They don't have any crampons. And each soldier has to be carrying plastic explosives. They got to be carrying their rifle with them at all times. And of course, they're wearing all sorts of winter clothes. So it's quite an incredible undertaking to say the least. So they finally pick upon the night of February 27th, 28th for their attack on this. So we're coming up on the 83rd anniversary, just in a couple of days of this whole thing coming off. So they ski from the hut to this area, to the south, to the north side of this chasm. They observe what's going on. They decide, okay, yes, we're going to climb down the gorge, climb over, climb up the other side. And they've got a couple of things going for them. Number one, it's unbelievably cold, as cold, if not colder, than anything that we've experienced here in the United States in the last couple of days. Which means that the guards, the German guards, they're not kind of walking around freely and keeping their eyes on everything. They're basically just trying to survive. They've got their eyes fixed on the suspension bridge, and that's about it. The other thing that the saboteurs have in their favor is that the turbines in the power plant, which is right nearby, are spinning all the time. And these turbines are enormous. I've been there. They're like about 25, 30 feet in diameter, and there's like eight of them. And they're all spinning at top speed. They spin 24 hours a day, 7 days a week, producing electricity. And by doing this, they kind of give off a humming, thrumming, like white noise that masks simple noises. So you're not going to have a question of breaking a twig and having it resound in the night darkness where it's all quiet. There's this background noise that kind of muffles just about everything. So they climb down, climb up the other side, break in surreptitiously, secretly into the basement of the heavy water plant. There's only a Norwegian guard on duty point. All the German guards are in a barracks nearby. They get down to the basement where all the heavy water electrolysis tanks are located. Here's what they look like. They plant plastic explosives on them, put on delayed fuses to allow them to get out of this, get back into the gorge, and get out to the other side of the gorge before the bombs explode. And they all go off, destroying all the electrolysis tanks, and about 1,000 gallons, literally and figuratively, end up going down the drain. So the Allies are absolutely ecstatic at this point. Of course, now the Gunnerside team has to make good its escape. And what they do is they break up into three parties. A couple of them ski to Oslo, where they join the resistance in Oslo. A couple of them go back to the hut, the cabin, to wait further instructions for additional resistance activities. And five of these saboteurs ski 200 miles, cross-country skiing 200 miles to the Swedish coast and to safety. So that if you watch any of the Olympics, you know these guys, the Norwegians, are not to be messed with when it comes to cross-country skiing. And even though the Germans bring in 3,000 soldiers and policemen to blanket this area to try to catch these guys, all of them escape without being caught. And not a shot was fired in the whole process. It was all done, secretly, without harming anything other than the heavy water facility itself. In fact, the German general who was in charge of security in Germany, a guy named Nicholas von Falkenhorst, says this was the greatest coup of World War II, that they were able to pull this off. And so the Allies are ecstatic. They think they've set back the German atomic war program by at least a year. They figure it's going to take the Germans 6 months to rebuild the plant, another 6 months of this painful electrolysis process to produce high-grade heavy water before they can start shipping it. Unfortunately, the Germans proved them to be wrong. Instead of taking 6 months to rebuild the plant, they rebuild it in 3 months. And by essentially working the Norwegian people in the plants kind of to death, I mean, they're working them on 3 shifts, they're able to get back up to production by the summer of 1943, all over again. So it's back to the drawing board for a third time. Now, the one difference in the complexion of the situation at this point is now the United States is heavily involved in the uh, conduct of the war. We've ramped up our armed forces from basically a standstill, from nothing before Pearl Harbor, to a much higher profile. And we've got the Eighth Army now stationed, the Eighth Air Force rather, stationed in northern England and Scotland. And the Americans say, hey, maybe you British aren't very good at precision bombing, but we've got the Norden bomb sight, and we can drop a bomb right on a dime. We're much better than you are. And so we think we can blow up and obliterate this plant. Just give us a chance to show you what our bombers can do. And so the Norwegians and the British are not particularly, they're kind of lukewarm over this, thinking it's not going to work. And the upshot, they're going to kill a lot of innocent civilians in the process, but they really have no other alternative that they can suggest. And the only concession the Americans make is that they plan their approach, their attack on this plant, that they will arrive over Vmork at roughly sometime between 11:30 a.m. and 12 noon, because that's the beginning of the workers' lunch hour, which means they're all going to be going back to Ryukin. They're going to cross over the suspension bridge, go back to their homes, so they won't be in the plant when it's under attack. So the attempt takes place on November 16th, 1943. So we're talking a full year now has happened since the freshman debacle, Operation Freshman, and 9 months after Operation Gunnerside was at least partially successful. 176 B-17s and B-24s are sent over to Norway. They drop 700 bombs, each bomb weighing 500 pounds, all high explosives. If you do the math, that works out to 175 tons worth of high explosives drop, and not one single bomb lands on the heavy water plant. It ends up blowing up just about everything else in the surrounding country, all the outbuildings. A couple of bombs land on bomb shelters, killing innocent men, women, and children, but it achieves absolutely nothing. So it looks like yet another failure on the part of the Allies. I mean, at this point, they've tried several missions, and none of them have been successful. Even Gunnerside was only partially successful. It slowed down the Germans for a little bit, but everything else has been a complete failure. So you can imagine they're getting pretty discouraged. But in war, I guess, as in life, there are sometimes these what we would call the law of unintended consequences. And in this case, even though the Allies think they're everything they try is not working, the Germans come to a different conclusion. They conclude that as long as this plant is there, that the Allies are going to keep trying to find some way to disable it. So the Germans decide that it's actually more prudent for them to disassemble the entire plant and move it lock, stock, and barrel, move all the equipment, move all the heavy water, whether it's at 1% concentration or 99% concentration, move it all back to Germany for safety. Now, again, one thing I've never been able to figure out in my research is what the Germans plan to do once they got all this back into Germany. It's not like they had an unused hydroelectric plant producing all this energy that you needed. But I guess if you're German and you have 9 million slave laborers working for you in occupied Europe in 1944, the idea of taking 100,000 of them and moving them into coal mines just to produce, a couple of thousand tons of coal to generate electricity for this power plant, I guess they were prepared to do this. So when the Norwegians get word that this is what the Germans are going to do, they're going to disassemble the whole plant and move it. They contact the team that's still holed up in the cabin up in the mountains, the Hardangervidda. They wire back to them on the radio saying, you've got to do something about this. The plan is they're going to move this all in the next 2 weeks. We don't have enough time to train any new commandos. We don't have time to drop any more soldiers or saboteurs in to help you. You guys on the ground have just got to figure out how to stop this from happening. And the man who's in charge, his name is Knut Hawklid, he says, okay, I can try to rush the bridge. That would be suicidal at this point because it's now more guarded than ever. I can try to go down the gorge like everybody else was somewhat successful in Gunnerside. But of course, the Germans have learned their lesson. They now are guarding the gorge. He says I can try to attack the transport. And at this point, it's worth viewing. And this is the Gunnerside team that was the team that was successful in accomplishing at least slowing down the German production. This is the map I showed you earlier. When Vmork was constructed back in the early 20th century, of course, they needed to get all this ammonia out to port in order to ship it to all the farmers around the world who want this fertilizer. So the Norwegians, being not being dummies at all, realized that to get this product, which is very bulky, to a port along the ocean, they've got to build a railroad track. Given the fact that they're surrounded by all these tall mountains, the best thing to do is just to follow the contours of the mountains, not to kind of blast your way through them. And since they've got this natural feature, this Lake Tunisia, which is about 27 miles long, they say what we're going to do is we're going to build a railroad line. It starts at Ryukyu, starts at the plant. It will follow the contours of the Mona River. And then here, rather than build 26 miles of railroad track, which involves a lot of blasting, what we'll do is we'll build a dock here and a dock way down here, and we'll build two ferries. And we'll just let the ferries take the chain all the way down. And so these ferries, the deck of the ferry will consist of train tracks. You can drive your train right onto the deck of the ferry and move it that way. So when Hochland is trying to look at where if there's any kind of weak link in the Germans' plan, he says, I can try to blow up the train, but of course the Germans have got soldiers on top of the train, in between the train cars. He says, I can try to blow up train tracks themselves. The Germans have put guards along the railroad track. Every 200 or 300 yards there's another guard. But Hochland says the one thing that the Germans didn't take any precautions with respect to on this plan is the ferry. And this is a picture of what the ferry looks like. And I know it's a little bit hard to read. There were two ferries. One was called the DF Hydro. This is called the DF Ammonia. That's what that sign is there. Because that's all this ferry has been doing for the last 2 or 3 decades is moving ammonia on railroad tracks that go up and onto the deck of the ferry along Lake Tinjo. So they find out that the Norwegians find out this ferry is going to leave on a Sunday morning, first thing Sunday morning when there's nobody around. The idea is nobody will be presumably being nosy and finding out what the Germans are up to. And so Hochland, who still has plastic explosives, he actually goes to a hardware store and buys an old-fashioned alarm clock, one with the bells on the top and the hammers that hit the bells. And he takes his plastic explosives, the alarm clock, and a battery, and he goes onto the deck of the ferry, the Hydro, the evening before on Saturday night. He accosts the captain, who is a Norwegian, and he says, "Sir, I've got some contraband that needs to be delivered to some of my comrades at the other end of Lake Tinjo. I can't tell you what it is. This is top secret, but this is for the greater good of Norway, and I'd like to hide it down in the bilge." And the skipper, being a good patriotic Norwegian, says, "Yes, I know nothing. I see nothing. I'm not going to question this." And so Hochland goes down into the bilge, takes the plastic explosives, creates a gigantic ring in the front of the bow of the ship, connects the battery to it, sets the alarm clock for 10:30 the following morning, so that when this ferry is midway through Lake Tinjo, that alarm clock is going to go off, the hammers are going to hit the bell, that completes the electric circuit, and it blows up sets off the plastic explosives. And by blasting a hole in the very prow and bow of the ferry, that means it's going to immediately fill up with water. The bow is going to go into the water, and the rudder and the propeller are going to come out of the water, which means the captain won't be able to steer it. And so the bomb goes off as scheduled, and the ferry sinks. Now, one thing I didn't mention in my initial remarks about Lake Tinjo is it happens to be one of the deepest lakes in all of Europe. It's somewhere between 1,300 and 1,500 feet deep. So when that ferry goes down, it stays down. Now, at that point, it's now March of 1944, and the Germans had much bigger problems on their hands, bigger fish to fry. The Russians are pressing in from the east. In a couple of weeks, the Allies are going to open the second front in Normandy at D-Day, June 6, 1944. So the Germans have to turn all their attention really to just survival. So the question really comes down, could the Germans have in fact developed an atomic bomb if they had been able to get all their hands on heavy water without all of this interruption that occurred along the way? And the one person who would know something about this was the head of Norway, or head of rather Germany's atomic war production, and that would be the equivalent of our Oppenheimer in Germany. His name is Kurt Deibner, And after the war, he was interrogated, and this is what he said in his interrogation. When one considers that right up until the end of the war in 1945, there was virtually no increase in our heavy water stocks in Germany, it will be seen that it was the elimination of the German heavy water production in Norway that was the main factor in our failure to achieve a self-sustaining atomic reactor before the war ended. So that's at least his view of what's going on. Personally, I think that the Germans would not have been successful. I mean, look at the Americans. We were devoting enormous resources, and even we did not develop the atomic bomb before World War II ended in Europe, at least. I mean, the war ended on May 8th. The first test of the Trinity wasn't until July of 1945, and then the first droppings were in early August. And it seems to me, if you back up and kind of look at this picture from the 40,000 foot level, it seems to me that Germany made two fundamental mistakes in their attempt to build an atomic bomb. The first one was, I'd call it a problem of hubris. And that is when the Germans looked at any kind of new weapon system, whether it was the atomic bomb or anything else, the question they would always ask, the acid test to them was, will this help us win the war? If it will help us win the war, then we're in favor of devoting resources to make it happen. If it's not going to help us win the war, then we're going to put it on a kind of a slower track. We're not going to give it the same urgency. And you have to go back. You know, it's easy in hindsight that we knew Germany was going to lose the war. That's not the way it looked in 1939, 1940, 1941. And when you think about it, September 1939, Germany invades Poland. They capitulate in 30 days. April 1940, Norway and Denmark are invaded. May of 1940, France and the Low Countries are invaded. They capitulate within months. Go to the following summer, June of 1941. Um, Now the Germans have invaded Russia, and their initial success is outstanding. They're capturing millions of Russian soldiers within the first couple of weeks of the war. In fact, their chief of staff, their army chief of staff, a man named Franz Halder, he wrote in his war diary on July 3rd, 1941, he says, it's not really too soon. I'm sorry. It's really, I can't read my own writing here. It's really not saying too much if I claim that the campaign against Russia has been won in 14 days. That's how cocky the Germans were that they were going to knock Russia out of the war. By the end of December 1941, the advanced units of the German army can see the spires of the Kremlin in their binoculars. That's how close they are to capturing Moscow. They knock Germany or Russia out of the war. How long can Britain, stand up alone at this point? So from the mindset of the Germans in 1941, the war is practically won. They're thinking about the post-war. They're not thinking about how much more fighting is going to go on. So when their own scientists are telling them that it might take 3, 5, 7 years to develop an atomic bomb, if it can be done at all, they're not particularly interested in this. Now compare that posture to the posture of the United States entering World War II. We are so much worse off leading up to Pearl Harbor. In the spring of 1940, the United States had the 18th largest army in the world. That was smaller than the armies of Belgium, Netherlands, Portugal, Spain, Sweden, and even Switzerland had a larger army than we did. Now, Pearl Harbor occurs December 7th, 1941, and 48 hours later, the United States finds itself at war with not one, but two of the largest, most successful, most powerful armies in the world. In fact, by the spring of 1942, Axis powers have controlled over 1/3 of the population and mineral resources of the world. That's what we're fighting against. So the American planners are saying the war is going to happen. It's going to take 3, 5, 7, 9. It might even take 10 years to finally subdue both Germany and Japan before it's all over. So with that time frame, we should be going full bore with trying to develop an atomic bomb because we can easily see where might need it before the end of the war is over. So in other words, the Germans never had the urgency that we had with the Manhattan Project. The other fundamental mistake I would say that the Germans made is that they had spent the greater part of the decade of the 1930s harassing and driving out of the country some of their most talented, brilliant scientists who just so happen to be Jewish. And that starts with Albert Einstein and works its all the way down to any number of these brilliant, brilliant scientists. And if these scientists themselves weren't Jewish, as the case of Enrico Fermi, who actually produces the first chain reaction at the University of Chicago in 1943, his wife was Jewish and she was being persecuted by the Italians. So he immigrated to the United States. So that's what happens, it seems to me, when you get ideology trumping science. I mean, science is either true or it's not true. There's no such thing as Jewish science that the Nazis were so upset about. They said everything that Einstein has written is rubbish. It's Jewish science, and we don't want any part of it. And of course, what they were doing is essentially shooting themselves in the foot. So I read a book not too long ago by an author named Evan Thomas. The name of the book is The Road to Surrender. And the way he writes is he says, it might be said that Hitler lost World War II on April 7th, 1933, when Germany banned Jews from the government because they were just losing all of this talent. A slightly more cheeky way of describing the same phenomena is attributable to Churchill's military secretary, who said, the Allies won the war because our German scientists were better than their German scientists. Now, that's not to take anything away from the efforts of the Norwegians involved in Operation Gunnerside and on the attack on the DF Hydro. I mean, they were all volunteers, and the Gunnerside team, they knew what had happened to the Grouse team, that they had all been executed by the Germans. So they knew what was going to happen to them if they got caught. And they all agreed to take cyanide pills with them. And they all agreed that even if they were just wounded, they would take cyanide rather than imperiling the importance of this mission. And when they left, the head of their group, who stayed behind, one of the Norwegians, his name was Leif Tronstad, he wrote, you do not know exactly why it is so important, but trust that your actions will live in history for 100 years to come. And here we are now, 80, 83 years since all that's happened, and we're still talking about it. And I'd be willing to bet they'll still be talking about the heroic efforts involved in the Heavy Water War come the 100th anniversary. And I'll leave you with one final quote. This is from the official historian of the SOE. It was a British by the name of M.R.D. Foote. A lot of initials there. And because he was the official historian, he knew about every activity the SOE engaged in throughout World War II, from the very beginning to the very end. And what he writes is, and this is a direct quote, if the SOE had done nothing else, Operation Gunnerside would have given it claim enough on the gratitude of humanity. And with that, I will conclude my remarks and thank you again for listening to my presentation. And if you have questions, I am more than happy to answer them at any time. So fire away, or if you've got anything at your end, Elizabeth, let me know.
Okay. Thank you so much, Tim. That was fascinating. I cannot believe the bravery of these people involved in
Yes.
these missions and all the efforts that was put in by the
Yes.
enemy, and unbelievable. So thank you. Fascinating history.
Yeah. And
And you brought it alive.
all of it because of that one little entry in
Yes.
this diary that set me off on this wild goose chase to learn everything about V-Mark. So
Yes. Thank you, Tim. I'm going to stop the recording so
okay.
people can feel free to come forward with questions. Again, thank you.
Perfect.